Alright, chapter 8.7 is all about the difference of squares, but before moving on, again, I would do a quick self-check. If the steps I use to factor this problem still confuse you, then I recommend working on the homework for the past 2 days before going any further in this video. Now, it doesn't mean you have to be perfect on everything I do. It just means that if I do something in this process that you don't understand, it means that you haven't practiced those main 4 steps enough, and it's only going to make it worse. So make sure when I go through this, again, while you copy this first problem, if anything I do does not make sense, and by not make sense I mean you're absolutely lost and you can't at least remember the step, then you probably want to go back. So what we do here is, first off, we translate this. Remember that it multiplies to be this number, which is negative 30, and it adds to make this number, which is in this case is negative 1. We then make a tree for 30, which is 1 times 30, 2 times 15, 3 times 10, 4 no, 5 times 6. We then look at this and recognize that since the bottom number is negative, or since it adds to make negative 1, that my big side should be negative. And since it multiplies to make a negative 30, it means the signs are different, which means here I am, and the numbers that make negative 1 are 5 and negative 6. We then take these number with here and do 10x over 5, and we do 10x over negative 6. We then reduce both of those. 10x over 5, or 10 over 5, turns into 2, which means that that actually is 2x over 1. And 10 over 6 turns into 5/3, which means that it's 5x over negative 3, which means in the end my answer is 2x plus 1 times 5x minus 3. Notice again that's 2 times 5, which is 10x squared, 2 times negative 3, which is negative 6, 1 times 5, which is a positive 5, there's your negative 1, and then 1 times negative 3, which is your negative 3. So we have undistributed that problem to put it back into its original packing. So again, if you've at least followed those steps, that means you're probably on the brink of where you need to be on. But again, if you have not mastered the translation, the finding of the numbers, the placing of the signs, the creation of the fractions, and the reduction of the fractions and all that, then you might need to go back before you move, because this isn't really going to help you until you're ready to see the factoring process. But today we're going to look at 2 tricks that must be considered when factoring. The first should be considered as the very first step here, from here on out, which is the GCF factoring. Because if you don't do that, then you're going to miss a couple problems here and there, because they set you up sometimes. In other words, what you need to be doing first from here on out is looking at your numbers 6, 20, and 16 and asking, is there anything I can take out of them? And of course the answer is yes. 6, 20, and 16 can all be divided by 2. And if you remember our last test, that's where we rewrite this as 3x squared minus 10x plus 8. We then do this number and leave the 2 on the outside. So what happens is we are actually looking for numbers that multiply to be 24 and add to be negative 10. From there, again, make your tree for 24. 1 times 24, 2 and 12, 3 and 8, 4 and 6. 5 is not on there. The 10 is negative, which means my big side is negative. The 24 is positive, which means that the signs have to be the same. And the numbers that make negative 10 are negative 4 and negative 6. Again, ignoring the 2, we want to put that number over both. So 3x over negative 4 and 3x over negative 6 is where we go. From there, reducing, again, common sense tells me I can't reduce 3/4, but just to make sure, there you go, 3/4 stays 3/4. Now 3 over 6, again, common sense says 1/2, but if you need to, just do your 3 over 6. Notice that I don't put the negatives in because I already know where the negative is. That is 1 over 2, which means that this stays 3x over negative 4, but this turns into x over negative 2, which means now my answer is not just these factors, it's 2 times 3x minus 4 times x minus 2. And again, the way you check that is 3x times x is 3x squared, not 6x squared. But 3x squared times your 2 is what makes your 6x squared. Alright, so again, just add to your step that you need to check GCF first. Every time, from here on out, the first thing you want to do is ask yourself if you can take a number out of every part. Make it your habit, make sure you check, get it into your system, because otherwise you're going to miss a couple problems here and there that are meant to throw you off by giving you a GCF. If you look at your second example on that, it's the same problem, and I want you to do it without a GCF just to show you what happens if you forget. So here we're looking for numbers that multiply to be, I think, 96 and add to be negative 20. So we make a tree for 96. 1 times 96, 2 times, I think, 48, 3 times 32, 4 times 2, 24, 5 doesn't go, 6 times 16, 7 I don't think goes, nope, because that would be 26, 8 times 12, 9 I don't think goes, 10 I don't think goes, 11 no, and 12 is already there. So again, the better you get, the more you can actually do that skill, because it's not so hard to do. Pardon me while I focus this thing to make sure it's clear for you. But this should be the whole thing. And so you're looking at the fact that 20 is negative, so that means the big side is negative. You're looking at the fact that 96 is positive, which means the signs are the same. And the numbers that make 20 are negative 8 and negative 12, which means I now take this and put 6x over negative 8, and I put 6x over negative 12. Reducing these two turns into 3x over negative 4. Reducing these two turns into x over negative 2, because that is 1/2, and this is 3/4. And again, based off of what I just did, you would naturally want to put 3x minus 4 and x minus 2 as your answer. So if you're not going to check GCF, at least do the multiplication and recognize that 3x times x is not this. And that's what tells you what's missing. And if you want to do it this way, then you can actually do the quick check, recognize that 3x times x is actually 3x squared, and that you need to multiply it by 2 in order to make it work. And that is where that number comes in. But whatever it is, you need to figure out a way to deal with the fact that there are going to be problems where the GCF is going to be an issue, and you need to address that, because if you do not, you're going to let a few problems go. And that's not a good idea, especially with the fact that you might just make silly mistakes on other questions. The second trick is one that you've seen introduced already. It's just factoring problems that have a value of 0 for the letter B, which is the middle value. Officially, these are called differences of squares, and it's because it has to be a subtraction sign, which I'll talk about in just a second. But it's a perfect square typically over here and a perfect square typically over here. But we can still use the same process we've been doing, because in this case we're talking about A being 4, B being 0, C being negative 25. And what you get there is you want numbers that multiply to be negative 100. Again, hopefully you saw this already, and add to be 0. Now here's the thing about it. If this was plus 25, then we'd be looking for number. Actually, we'll do this first. So if you do your tree for 100, you got 1 times 100, 2 times 50, 4 times 25, 5 times 20, 6, 7, 8, 9, 10 times 10. 0, pretty much let's just view it as a positive, so we'll just leave this as plus. But the trick is, because this is a negative 100, it means the signs are different, which means that you put a negative here. And when you're looking for the ones that make 0, of course, it's 10 and negative 10. Now here's where you have to be careful, because if that's a positive 25, you can't do it, because then it would make a positive 100. And remember that a positive 100 would mean whatever sign's over here is over there, which means your 10s would not cancel. Positive and positive does not make 0. Negative and negative does not make 0, which is why it must be differences of squares, which is a perfect square minus a perfect square. Everything else is the same. 4x goes over negative 10. 4x goes over 10. You then reduce that to be 2x over negative 5. And 2x over 5, and from there you have your factors of 2x minus 5 and 2x plus 5. Now let's think back to last chapter. There was a point when we multiplied these things and the middle term went away, and it was what we called conjugates. I believe that was when I couldn't speak at all because I used the word conjugates, and that's whenever you have the same numbers but just different signs, because notice 2 times 5 is positive 10, negative 5 times 2 is negative 10, which is why those 10s cancel, leaving you just 4x squared minus 25. So that is what's going on. Now there is a shortcut you can use if you get really good, and that is to recognize that the square root of 4x squared is 2x, and the square root of 25 is 5, and all you have to do is write it and put the different sign. But again, if I were you, if I'm going for this as something that I'm trying to make sure I get right, I would not rush it. I would just take my time and follow this system, because this system is the same system you should have been using the last 2 days. And why not? Why go with something that is a whole different strategy, especially when you're going to learn a secondary strategy, or for some of you a tertiary or third strategy tomorrow. So let's just go ahead and stick with that pattern, because there's no need in making things more complex than they already are. Now, once you recognize that there is no x, we already know it adds to be 0, so what we're going to do is 49 times 36, which is 1764. So we're looking for numbers that multiply to be negative 1764, and again add to be 0 because there's no x. There's an easier way to do this. Instead of making the tree for negative 1764, we understand that in order for it to be 0, it has to be the same number on both, because otherwise they don't cancel. What leaves, or what tells you the number that multiplies by itself to make a number, is the square root. And so the easiest way to do this is to do the square root of 1764, which tells me that the square root of it is 42. The other thing we know is because it makes 0, one of these should be a positive 42 and the other should be a negative 42. And just to show you, 42 times negative 42 equals negative 1764, which is what we want. So again, whenever you do this and it equals 0, the easiest thing to do is take the square root of that number, because that tells you what the number is. Instead of going through all the numbers down to 42, just square root the number, find out what it is, and go from there. But once we get that 42, we now do 49x squared over 42. I'm sorry, not x squared, 49x over 42 and 49x over negative 42, and we reduce them both. So 49 over 42 is 7 over 6, which means it is 7x over 6. This, of course, is going to give me the same thing, except it's going to be 7x over negative 6, which means my final answer is 7x plus 6 and 7x minus 6. And again, the way you can check that, 7 times 7 is 49, 6 times 6 36. You know you got it right. Do not be afraid to check your work. I actually suggest checking your work, because if you do that, you minimize the chance of making silly mistakes on that stuff. The last question, C, puts together the trick that we talked about, because when you look at 27 and 192 and then you square root 5184, let's see if it works. It actually does work, but that's not good, because this is not a perfect square. 27 is not a perfect square. 192 is not a perfect square. There's nothing that multiplies to make 27 or 192. And so remember what I told you you're supposed to check first, which is whether something can go in. So if I were you on this, I would do 27 over 192 equals. And then the trick that I showed you was to do 27 divided by 9, because it obviously goes, which tells me I can actually pull out a 3 and turn this into 9x squared minus, I believe, 64. From there, I would do the work, again ignoring the 3. 9 times 64 is 576. And again, adding to be 0, I'm sorry, negative 576 and adding to be 0. And then I would square root the 576, because again, if it adds to be 0, it's got to be the same number, telling me that my number is 24 and 24, with one of them positive and one of them negative, because those two make 0. Again, from there I would take my 9x and put it over 24, take my 9x, put it over negative 24, and reduce that fraction, which is 3 over 8. So you end up with 3x over 8, 3x over negative 8, and in the end your answer is 3x plus 8, 3x minus 8. But don't forget that you had a 3 that you pulled out. And again, your check could be 3 times 3 is 9. That is not 9, and what you multiply by that to make it 9, to make 27, is the 3, which then would finish off your question. Again, work hard on this. The good news, again, even if your head is spinning a little bit, that's natural, is that you have today's lesson, you've got tomorrow's lesson, and then you've got all weekend to practice, and then you have Monday and Tuesday to only practice, 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 and then the test is Wednesday for you to go ahead and put all of that together. Now again, I recommend those of you who have phones with internet access that you do as much work as you can to fight to practice, because you can do Math XL on your phone. That is why I chose it. And again, you do not want to say that you tried your best if you did not really fight and do as much extra work as you could possibly do. So other than that, go ahead and move on to your Math XL, and again, work me to death if you need to ask questions. Good luck.